In this lesson, we're going to begin Chapter 1, Section 6b, where we're going to solve radical equations and equations with rational exponents. All right, now to solve radical equations, right, think about how we solve equations involving an x squared, right? So let's say I had x squared equals a number, right? To get rid of that square, we would do the opposite of squaring, which is square rooting, all right? Now we'd essentially do the same thing, just in the opposite direction, right? If I have the square root of x equals a number, right? The opposite of square rooting is squaring, right? So we kind of go in the opposite direction in this case, all right? So to solve a radical equation, we're first going to isolate the square root, so get it by itself. Square both sides to cancel out the radical. Solve whatever equation is left over, right? Sometimes it's a linear equation and sometimes it'll be a quadratic equation where you have to factor. And then the last thing is you want to check for extraneous solutions, right? The only other time that we've seen extraneous solutions were rational equations. So for example, something like 1 over x equals 5, right? So we would solve this like normal, right? Get an answer, but you wanted to make sure that the bottom, right, did not equal 0, all right? And that was our restriction here, right? So with checking for extraneous solutions, in this case, it's going to be a little bit more tedious. And you're going to see, as we do some more examples, some of the work gets a little excessive, but necessary to make sure that our solutions are valid, all right? So let's just start with some examples. Something like the square root of x minus 7 equals 6, right? The first step, isolating the radical, is already done for us, right? We already have a radical on one side and then a number on the other, right? So what we would do is we would very simply just square both sides, right? Because that square is going to cancel out with this square root. So then we end up with an x minus 7 equals 6 squared is 36. And then we would solve this like normal, right? So plus 7, and so I get x equals 36 plus 7, which is 43. And then we get 43 as our answer. All right, our original equation looked normal, right? It just looked like a radical equals a positive number, which is going to be true, assuming that we solved and did the correct math. But just to prep you guys for what you're going to see in the next slide, I'm going to check this answer, right? So to check this answer and make sure that it works, I'm just going to plug in 43 into the original equation. So I get the square root of 43 minus 7 equals 6. Square root of 36 equals 6, which is a true statement, right? I get 6 equals 6, right? So this does work, all right? And then we can do the same thing with the next one, right? The next one, however, the radical is not isolated, so I want this completely by itself, all right? I have a plus 12 on this side with that radical, so I can move that to the other side. So I'm going to subtract 12 on both sides. And so we get the square root of 2x minus 6 equals negative 12. All right, and then again, to get rid of that square root, I can square both sides. All right, and so we end up with the 2x minus 6 equals negative 12 squared is 144. And then we solve this linear equation as normal, right? From here onwards, it's really not so bad. So I get 2x equals 150. Divide by 2, and I get x equals 75. All right, so we did all of this. Our math makes sense, right? We just need to plug this back into the original equation to check. Our check is going to be, right, so I get the square root of 2 times 75 minus 6 plus 12 equals 0. So I get the square root of 150 minus 6 plus 12 equals 0. And then we just keep going, the square root of 144 plus 12. All right, and the square root of 144 is 12. So I get 12 plus 12 equals 0. And then we see that when we plugged in 75 into our original equation, we end up with a false statement. I end up with 24 equals 0, which is not true. Right, so this one actually has no solution. Right, so even though we mathematically got 75 as an answer, right, it didn't make sense when we plugged it back into the original equation. So this one actually has no solution. Right, we'll just cross this out. And then we can even see from this step, right, even from here, we could have seen right? The square root of 2x minus 6 equals negative 12, right? Similar to what I talked about before, maybe in another lesson, right? The square root can never equal a negative number. So if I'm seeing that the square root of this expression equals a negative 12, right, there's nothing that I can plug into this expression that's ever going to get you a negative number. All right. I know we've worked with i's before, right, to handle the square root of a negative, but I can't square root something and then get negative from that. All right. So that's just a special case that you need to be aware of, and you're going to see in all of the examples involving square root equations, we're going to check our answers. All right. All right. The only other times where these kinds of problems get a little bit more complicated is maybe if there's a variable on the other side, or maybe a variable plus a number, right? So this process is still the same though, right? I have a square root on one side, everything else on the other. I can just square both sides, all right? And then you're left with an x squared equals, right? This square root and this square are going to cancel out. So I get x squared equals 15 minus 2x. And then you notice here you're left with a quadratic equation. So I'm going to subtract 15 and add 2x on both sides to get it equal to 0. And then we solve this as normal, right? This is going to get us an x squared plus 2x minus 15 equals 0. All right? And then this is factorable. All right? So then when we factor this, we get x plus 5 and x minus 3 equals 0. All right, so set both of these equal to 0. X plus 5 equals 0. X minus 3 equals 0. And I get x equals negative 5 and x equals 3. All right, now the tedious part here is to check your answers. All right, so let's first check x equals negative 5. All right, now when you check x equals negative 5, we get negative 5 equals the square root of 15 minus 2 times negative 5. And then we get negative 5 equals the square root of 15 plus 10. And then we get negative 5 equals the square root of 25. And then we see that this isn't true, right? Negative 5 equals 5, right? That's a false statement. So x equals negative 5 is not a valid solution. All right, let's check x equals 3. All right, when we check x equals 3, I get 3 equals the square root of 15 minus 2 times 3. 3 equals the square root of 15 minus 6. 3 equals the square root of 9, and 3 equals 3. So this one does work. So our only answer here is 3. All right, so that's why when you guys go into WebAssign and plug in your answers, maybe you solve it and then you get both of these. All right, but if you plug in both of them into your answers in WebAssign, right, it's going to mark it wrong just because you have to check and make sure that they're both valid solutions. All right, now I can do the exact same thing with this next one. All right, again, I want my radical isolated. So you can either subtract the x or you can add this entire radical. All right, and just to keep our signs all positive, right, we don't really like working with negatives, I'm going to add this radical to the other side. So it's going to be a plus 3x, or plus the square root of 3x plus 18 on both sides. And then we get x equals the square root of 3x plus 18, and then we see that this is something that we can solve just like we did in the previous problem. All right, square both sides to get rid of that radical. So then again, x squared equals 3x plus 18. And then solve it again like normal, right? Get everything on one side, set it equal to 0. And so we get an x squared minus 3x minus 18 equals 0, and then factor it. Right, this factors into x minus 6, x plus 3. All right, and then we get x minus 6 equals 0, x plus 3 equals 0, and so we get x equals 6 and x equals negative 3. All right, now we get these answers. Mathematically, they make sense, but we do need to check to make sure that they're not extraneous. So I'm going to start with x equals 6. So plugging in x equals 6, we get 6 minus the square root of 3 times 6 plus 18 equals 0. So we get 6 minus the square root of 18 plus 18 equals 0. 6 minus the square root of 36 is 0, and the square root of 36 is 6. So I get 6 minus 6 is 0, which is true. So 6 is one of my answers. Now let's check x equals negative 3. 1, right? So we get a negative 3 minus the square root of 3 times negative 3 plus 18 equals 0. Negative 3 minus the square root of negative 9 plus 18. All right, then you can kind of see from here that it's not going to work, but just to finish it up, if you need it to be clear, right, I get 3 minus the square root of 9, which is negative 3 minus 3 equals 0, right? And negative 3 minus 3 is negative 6. And negative 6 does not equal 0, so we only get one answer here, and it's x equals 6. All right, so that's really the tedious part of this, this section, right? The actual math itself, hopefully we're seeing, is not crazy difficult, but again, it's just the tedious part of checking your work, right? It's not as simple as plugging into the denominator like we did in rational equations, right? It takes a little bit more work, but it doesn't have to be super rigorous, right? Sometimes you can see at a certain point that it's not going to work. So if you see that, you don't have to finish it all the way. What's most important is that we see this work right here, right? And this is just extra for you guys. All right, still important to make sure that we get the correct answers by the end of it. But again, this is just extra, meaning I don't need to see each and every single step in this process right here, right? And all this to the side. All right, let us continue with these kinds of problems, right? So something like number 5, again, you still want to get the radical completely by itself on this side of the equal sign, right? In this case, it is. So then I would square both sides, right? Keep in mind when you square both sides over here, I need to square this entire expression on the right-hand side. So although on the left-hand side, the square root and the square cancel out, I get an x minus 1, right? It doesn't work that nicely on the other side, right? On the other side, I get an x minus 7 squared. And then keep in mind, anything to the second power, I can write twice and multiply it. So I get an x minus 7, and then you would have to FOIL this out. All right, so then I get an x minus 1 equals, when you FOIL this out, right? I'm not going to show this part of it. If you need to do more work to verify that this is the answer, you can. All right, but this is going to get us x squared minus 14x plus 49. All right, and then again, it's another quadratic equation, so I'm going to get everything to one side and set it equal to 0, right? So I'm going to subtract x and add 1, and we get an x squared minus 15x plus 50 equals 0. And then I need factors of 50 that add up to negative 15. So this is going to get me an x minus 10 and an x minus 5. All right, and then you just set both of these equal to 0, right? So x minus 10 equals 0 and x minus 5 equals 0. And so we get x equals 10 as one answer and x equals 5 as another. All right, but then once again, you always want to check, right? I'll do that to the side here. All right, my check is going to be, I'll start with x equals 10. All right, so starting with x equals 10, I get the square root of 10 minus 1 equals 10 minus 7. And then 10 minus 1 is 9, so I get the square root of 9 is 3. Right, 10 minus 7 is 3. Right, which is valid, right? So x equals 10 is a valid solution. All right, let's try the same thing with x equals 5. All right, now when x equals 5, I get the square root of 5 minus 1 equals 5 minus 7. All right, and you can see on the right-hand side, 5 minus 7 is negative 2. So we can kind of already see that this isn't going to work. But if you need to keep going to verify and see it for yourself, right, the square root of 4 is positive 2, right, not negative. So then 2 equals negative 2, that is not a true statement. So x equals 5 is not a valid solution. All right. Now, I want to be clear and say that just because in these past few examples, one of our answers worked and the other one didn't, that's not always going to work out. You're not always going to get one out of your two solutions that are going to work, right? Sometimes you get both solutions do work. Sometimes you get neither solutions work, right? So that's why you need to check both of them, right? It's not like one works so the other one shouldn't work, right? If this one didn't work, then the other one has to work, right? That kind of thing, all right? That's not how it works, right? And I'm not sure if I put in this particular set of notes that both of them work or if there's a no solution, but that's just something to keep in mind, that it's not always going to work out that way, all right? So number 6 is the last one of this kind. all right, where we want to get this radical by itself, and then we move everything else to the other side, right? So I need this by itself. So to get it by itself, I'm gonna add x on both sides, and then I can add the 1, right? So add whatever's not underneath the radical. And then these are gonna cancel out over here, and then I'm left with the square root of x plus 7 equals x plus 1. And then now that I have the radical by itself, I can go ahead and square both sides. But keep in mind, again, just like before, all right, squaring this right-hand side, x plus 1 squared, that's not just going to be as simple as the left-hand side where the square root and the square cancel out. So this is going to be an x plus 7. On the right-hand side, I have x plus 1 squared, which is the same as x plus 1 times x plus 1. All right, so then I get x plus 7 equals, again, you would FOIL this, and this is going to get you, when you simplify it, x squared plus 2x plus 1. All right, and then this becomes a quadratic equation that you can solve like normal, right? Get everything to one side, set it equal to 0, and so I get an x squared plus x minus 6 equals 0. All right, and then so now I need factors of -6 that add to 1, and it's going to be a positive 3 and a negative 2. All right, equals 0. And then I can set both of these factors equal to 0. So x plus 3 equals 0, x minus 2 equals 0. And then so as my two answers, I get x is -3, and I get x is 2. All right, so although we get these as answers, we do need to check. All right, so I'll check first x equals -3. All right, so make sure you're plugging into the original equation. All right, so then I get a negative x, so a negative -3, plus the square root of -3 plus 7, minus 1 equals 0. Negative 3 becomes a positive 3, so I get 3 plus the square root of 4, minus 1 equals 0. And then I get 3 plus 2 minus 1 equals 0. And then I get 5 minus 1 equals 0. All right, which does not work. I get 4 equals 0, which is not true. So that means x equals -3 is not a valid solution. All right, now let's check x equals 2. All right, now when we check x equals 2, I get a -2 plus the square root of 2 plus 7 minus 1 equals 0. And so we get a -2 plus the square root of 9 minus 1 equals 0. And so I get -2 plus 3 minus 1 equals 0. All right, which gets us 1 minus 1. So we do get a true statement, right? 0 does equal 0. So that means x equals 2 is one of our solutions, right? Our only solution. All right. All right, so that's it for this first half, right? The second half is going to be slightly different, but still kind of ties into what we were doing for these first 6 examples. All right, so other roots and exponents, right? So if, let's say, you have a radical that isn't 2, so for example, the cube root of x equals a number, or the fourth root of x equals a number, it's still the same thing, right? So you would isolate the radical, you would raise both sides to the power of the index, and then you would solve as normal. If it's a rational exponent, you would raise to the power of the least common denominator of all the exponents, and then you would simplify and solve, right? There might be other ways to do it. I believe that maybe some other people might do the reciprocal, right? So, or the reciprocal. Another way that I do it is I change it from rational exponents form to radical form. So for example, something like x to the 3/2, remember that that 2 on the bottom becomes the index of our radical. So this becomes the square root of x to the 3rd power, right? And sometimes I like to do it like that. Let's just try some examples and we'll see how we're going to do them. All right, so let's look at number 7. All right, lots of 7s in this example, right? So I see the 7th root of 3x plus 7 equals the 7th root of 4x plus 2. All right, so although it might look kind of crazy, all you have to do is you're going to raise both sides to the power of your index, right? And your index in this case is 7. And then the 7s are going to cancel out, And then so what you're left with is a very simple linear equation. I get 3x plus 7 equals 4x plus 2. And then we solve this as normal, right? So subtract 4x and subtract 7. And then we end up with a negative x equals a negative 5. We can divide by negative 1 and I get x equals 5. All right, very simple. All right, and then you can plug this in and make sure it works. In general, the odd roots are more likely to work than the even roots. Just because with even roots, the biggest thing that we take issue with is the negatives, right? We can't have negatives under the radical, and I can't have it equal a negative, right? But in this case, cube roots and seventh roots, fifth roots can all equal negative numbers. So there's really no big issue there. So I'm going to say the seventh root of 3 times 5 is 15, and 15 plus 7 is 22, equals 4 times 7. Sorry, right? I don't know why I wrote 7. Right, it should be 4 times 5. 4 times 5. Right, 4 times 5 is 20, and 20 plus 2 is 22. So I get the seventh root of 22 is equal to the seventh root of 22. I don't know exactly what that number is, but you can clearly see that this is a true statement, right? These two things are equal to each other, so this does work. All right, good, right? And now let's try the same thing with number 8. Again, I have a higher index. I have a fourth root. So what I'm going to do is I'm going to raise both sides, right? It's already isolated. I don't need to get it by itself. It's already by itself to the fourth power, right? Because that 4 and this 4 are going to cancel out. And then you're left with x squared plus 6x equals 2 to the fourth power is 16. And then if you look at this, you're left with a regular quadratic equation. So I'm going to subtract 16 on both sides. I get x squared plus 6x minus 16 equals 0. And then we get an x plus 8 and an x minus 2 equals 0. All right, so then we set both of these equal to 0. Right, x plus 8 equals 0. X minus 2 equals 0. And then we get x equals negative 8 and x equals 2. All right, now let's check that these are valid solutions. I'm going to check x equals negative 8. All right, so checking this one, it's going to be a negative 8 squared plus 6 times negative 8. Right, fourth root of that is 2. And so I get 64 minus 48. Right, fourth root of that is 2. Fourth root of 16 is 2, right? And this is true, right? The fourth root of 16 is 2. If you need to make the factor tree to verify, right, you can, right? But 2 equals 2. So x equals 8 does work. Now we can try the same thing with x equals 2. All right, so for x equals 2, I get a 2 squared plus 6 times 2, right? Fourth root of that equals 2. And so you get a 4 plus 12 equals 2, and so I get the fourth root of 16 equals 2, right? Which is exactly what we got before, which is 2 equals 2. All right, that does work. So in this case, both answers do work. So again, you don't want to rely on one of them working and the other one not working, right? Sometimes both of them work, right? In this case, they do. All right, so now let's try ones with rational exponents. All right, there's a couple different ways that you can do these. I like to do these in multiple steps just to make sure that we really understand what's going on, right? Because if you try to do too many things at once, you might get confused, right? There's a way that you could do it by using the reciprocal, but I would rather just eliminate one thing at a time. All right, so when it looks like this, if you look at your two sides, right, they both have an exponent that has a 5 on the bottom, right? So I'm going to raise both sides to whatever my common denominator is, all right? And in this case, it's 5, right? 5 is my common denominator. Now, if I raise both sides to the 5th power, all right, hopefully we see that this 5 and this 5 are going to cancel out. Because of power to power, you're going to multiply those powers. All right, and if I do 2/5 times 5, the 5s cancel out and you're just left with the 2 on top. All right, so the left side of the equation is going to become an x minus 3 squared. And then the other side of the equation, again, 1/5 and 5, the 5's are going to cancel, so I get 4x to the first power, which is just 4x, right? And then I can solve this equation, right? Remember that the square means that you're multiplying by itself twice. So I get an x minus 3 times an x minus 3 equals a 4x. And so we get an x squared minus 6x plus 9 equals 4x. And then we solve, right? So subtract 4x on both sides. We get an x squared minus 10x plus 9 equals 0. And then this is factorable, right? I get x minus 9 and x minus 1 equals 0. All right, and then so I get x minus 9 equals 0, x minus 1 equals 0, and so we get x equals 9 and x equals 1, right? Now when you go to plug these back in, they do work, right? And I'll show you, right? So the check over here is going to be 9 minus 3, right? So I'll check x equals 9 first. So I get 9 minus 3 to the 2/5 equals 4 times 9 to the 1/5. All right. So then 9 minus 3 is 6. I get 6 to the 2/5 equals 4 times 9 is 36 to the 1/5. All right. And you can evaluate this however you need to, right? So you can see that these 5's are going to go out front as the index of your radical. So I get the 5th root of 6 squared equals the 5th root of 36, right? And 6 squared is 36. So I get the 5th root of 36 is the 5th root of 36, right? And I don't know what that number is exactly, but I do know that these numbers are identical, right? And if you do the same thing with 1, we'll see that it's going to work out, right? So x equals 1. I get 1 minus 3 to the 2/5 equals 4 times 1 to the 1/5. And then again, I can do the same thing, right? So convert it into any way that you need to. So I get negative 5 5th root of negative 2 squared equals the 5th root of 4, right? And that's the 5th root of 4 equals the 5th root of 4, right? So it does work, right? So these are both valid solutions, right? Both of our answers work, all right? Now I can try the same thing over here. This one might get a little bit trickier, right? I feel like every class I show this example to, they kind of mess something up a little bit, all right? So if you look at the bottom, right, the 4 and the 2, our least common denominator here is between 4 and 2, it's going to be 4. But keep in mind, you're raising this entire thing, right? Both sides of this to the 4th power, all right? So that means that it's not just this 4 and this 4 on the bottom that are going to cancel out. It's going to have to go to this 3 as well. This 3 is not attached to this x. So it's going to be 3 to the 4th power, and then x to these 4 cancel out. It's going to be x to the 3rd power, all right? So again, because this 3 was not attached to the x, right? I didn't see parentheses around both of these that's being raised to the 3/4, right? They're each separately being raised to different powers, all right? So I'm going to raise both of them to the 4th power. So I get 3 to the 4th times x to the 3rd equals, and then I don't have to worry about that over here because there's only one thing, right? 1/2 times 4 is going to get you 2, so I get an x squared. All right, and then simplifying this, I get 81x to the 3rd equals x squared. And then we're going to subtract x squared and then set it equal to 0 because this becomes a polynomial equation, equals 0. All right, and then so I can take out an x squared, and I'm left with an 81x minus 1 equals 0. And then we get x squared equals 0. And 81x minus 1 equals 0. All right, you can square root both sides over here, and I get x equals 0 just once. Right, plus minus 0 is just going to get you 0, right? And then over here, I can add 1 to both sides, and then we get 81x equals 1, and then divide by 81. And so I get x equals 1 over 81. All right, so these are our two answers. Again, you can check these. They're both going to work. So just for the sake of time, I'll just leave it, and you just have to trust me on that. All right, so we'll do two more examples, pretty similar to what we've already done, right? Again, if I see the same index, I'm just going to raise to the power of the index, right? Isolate them, make sure they're separate. And if I raise both sides to the fifth power, all of these 5s are going to cancel out, and so I'm left with a 2x squared minus 1 equals a 5x plus 2, all right? And then this becomes a quadratic equation where I can get 0 on one side. So I'm going to subtract 5x, subtract 2. And so I get a 2x squared minus 5x minus 3 equals 0. And then this is factorable, right? 2 times negative 3 is going to get you negative 6. And factors of negative 6 that add to negative 5 are a negative 6 and a positive 1. So we get x minus 6, x plus 1 equals 0. I can take whatever number's in front and divide by 2. All right, x minus 6 divided by 2 is 3. 1 over 2, that doesn't simplify, so it becomes a 2x plus 1 equals 0. And so I get x minus 3 equals 0, and 2x plus 1 equals 0. So we get x equals 3 as one of our answers. And then once we solve this other side, I get x equals negative a half as my other answer. All right. Now again, these are going to work. For now, you can trust me on that. If you want to check them on your own, you can, but they do work. All right. And now let's try the same thing over here. Again, we can get one of our expressions with the rational exponent isolated. So I'm going to add 3x to the 1/3 on both sides. All right, so then I get a 4x to the 2/3 equals 3x to the 1/3. And then again, you can raise both sides to the power of the denominator. So I'm going to raise to the power of 3, raise to the power of 3, and that's going to cancel out these 3's. But keep in mind, just like before, I can distribute to both of these. This is going to go to both of these factors over here. So this becomes 4 to the 3rd, x squared equals 3 to the 3rd x, all right? And so this is just going to become 4 to the 3rd power is going to get you a 64. X squared equals 3 to the 3rd power is 27x, all right? And then this becomes a quadratic equation. I'm going to get everything on one side, set it equal to 0. All right, so we get 64x squared minus 27x equals 0. And I can take out a GCF of x. And then I'm left with 64x minus 27 equals 0. And so we get x equals 0. And 64x minus 27 equals 0. And so we get 0 as one of my answers. And then over here I can add 27 to both sides. And I get 64x equals 27. Divide by 64. And I get x equals 27 over 64 as my other answer. Now once again, both of these work. Again, for now you can just trust me on that. But if you want to check them on your own, you can. Right? But I know it's kind of a longer lesson. Right? Intended to be split into 2 days. If needed, I think it could fit into one class period, but right, slightly longer of a lesson, right? Lots of different things covered.